Today is yet another class. I'm Dr. B, your chemistry teacher. Today we are going to be talking about electrolysis, an aspect of it that is called the electrochemical cell. Electrochemical cell. Electrochemical cell. That is what we are going to be looking at today. Electrochemical cell, an aspect of electrochemistry. Do you know that the electrochemical cell is meant to do two things? One is either it facilitates a chemical reaction that is taking place inside the cell, or it generates electricity. I'm sure you're aware of this. You're not hearing for the first time. Today we're going to see how this plays out. It's important for us to know that we do not have just one type of an electrochemical cell. We have two. We have a galvanic cell, and we also have an electrolytic cell. We have a galvanic cell, and we have an electrolytic cell. These two forms the electrochemical cell that you hear about now and then. There is something that differentiates these two cells, even though they belong to that particular heading, electrochemical cell. For a galvanic cell, it makes use of the chemical reactions that take place in the cell to do what? To generate current or electricity. Which implies that redox reactions that take place here are all spontaneous. They take place on their own. So we can simply put it that in a galvanic cell, there is a conversion of a chemical reaction energy into what? Into electricity, which is electrical energy. So you convert chemical energy into what? Into electrical energy for a galvanic cell. But for an electrolytic cell, what happens there is simple. You do not need to have the reactions, the chemical reactions, supply electricity. What you need is simple. You need to supply the electricity, the current, to the system, to the cell, to allow the functionality or allow for the functionality of the reactions of the chemicals in the system. So in this, we say that for an electrolytic cell, there is rather a conversion of what? Electrical energy into what? Chemical energy. And in this situation, redox reactions that takes place in this kind of electrolytic cell are always non-spontaneous. And that is the reason why they involve what? A little supply of electricity or current for the chemical reactions in the system to take place. Now let us take a look at a general diagram of an electrochemical cell. Okay, so for an electrochemical cell, we have something like this. And we have another one like this. And in here, there is a solution. In here, there is also a solution. Now, there is a connection between these cells, between these systems. And this connection is what we typically call a salt bridge. A salt bridge. Usually, it's potassium chloride. And then we also have what we call electrodes. These electrodes that we have here are always negative and positive electrodes. They are connected to themselves and are also connected to what we call a voltmeter. A voltmeter. The electrode this way is always seen as the anode, and it is always positive. Usually, this electrode is always set to be oxidizing. So oxidation takes place here. And this electrode here is always known to be the cathode. The cathode, always negative, and it's always known to be reducing here. So reduction takes place here. Reduction takes place. So you can see that you have two electrodes. One is an anode, the other one is a cathode. The one that is an anode is positively charged, and there's always an oxidation reaction taking place there. The one that is the cathode is always a negatively charged cathode, and reduction reaction always take place there. But this is not all. Now, the solution that you have here, let's say for example what we have here is zinc sulfate. Let's say we have zinc sulfate here, we also have copper sulfate here. These are the solutions. From what we described earlier, if this particular solutions we have here happens to be what will undergo chemical reactions in order to generate current or electricity, then we are saying that there is a chemical energy being converted to electrical energy. In that case, we are describing what? We are describing a galvanic cell. But where we decide to introduce some current that will help to drive these particular reactions or reactants, then we are saying that there is a conversion of what? Electrical energy to what? Chemical energy. In that case, we are rather describing what we call an electrolytic cell. Now, we need to know something very important here. That because the anode has to do with oxidation, it is always where you have electrons being expelled. So electrons will always leave here, and that is why you always have electrons leaving here and coming into the cathode. So electrons are always leaving from the oxidation end, which is the anode, to what? The cathode, which is the reduction end. So the cathode is where electrons are consumed, and the anode is where electrons are made. Now, there is something very important about this electrochemical cell. Remember that the salt bridge that you have here has a function. The function is to balance the ions between these two solutions. You may decide to wonder, we are having zinc and copper, and we are talking about negative, positive charge and negative charge. Yet, both zinc and copper are all supposed to be positive. Exactly, you are right. But the truth remains that if you look at their placement in the electrochemical series, one is up and the other one is down. So, the one that is closer or away from 0 point, is calculated or being taken as being what? More negative. And the one that is above 0 is always seen as being more positive. Even if both of them were positive, the one that is getting closer to the 0 point is seen to be more negative. And the one that is away from the 0 point is seen to be more positive. So even though both of them are metals and both of them are positive metals, one can still be used as what? As a cathode, and one used as what? An anode, depending on their placement in the electrochemical series. Now, from this, it means that we can possibly have a half-cell equation or half-cell reaction. This means that zinc is reacting with what? Zinc reacting with zinc sulfate, okay? And zinc is actually solid and this is aqueous. And copper sulfate, which is aqueous, is reacting with copper. Now, the implication here is simple, is that at the anode, there is an oxidation of zinc. So that means we'll have to write that oxidation equation, which says zinc oxidizes to give us zinc 2 plus what? Plus 2 electrons. That is the oxidation reaction. And in the cathode, which is a reduction reaction, copper is reducing. So we have to write the redox reaction for it. So we are saying here, copper then, 2 plus, is reducing. So it has 2 electrons reducing to give us copper. So here it means that zinc is being oxidized. Therefore, zinc is what? A reducing agent. Copper is being what? Reduced. So copper itself is what? An oxidizing agent. Beautiful. This is how a typical electrochemical cell look like. So whenever you are looking at an electrochemical cell, it is important for you to note that electrochemical cell can either be seen as a galvanic cell or be seen as an electrolytic cell. And if it is seen as a galvanic cell, it means that you do not need to supply what? Supply electrical energy to the system. So it is the chemical reactions that take place there that bring forth what? Electricity. So there is what? A conversion of a chemical energy to electrical energy. And if you are looking at the electrochemical cell as what? An electrolytic cell, then it means that you need to supply some little bit of current that will ignite the reactions in the system. So you are converting what? Electrical energy into what? Into a chemical energy. An example of this is your automobile batteries, car battery. Do you know that a car battery plays a dual capacity in terms of what it is as an electrochemical cell? That if a car battery is being used in a car, it is playing the role of what? Of an electrolytic cell, because you need to charge it for it to do what? To supply the required energy to ignite the car. But where you are not using the car battery, perhaps it's charged already, and you are using it to power probably your appliances in the house. At that point, it is playing the role of a galvanic cell, because at that point, you do not need to supply any current to the battery. It is already the stored energy that comes as a result of the chemical reactions that are taking place in there that supply the electrical energy to your systems. So we can summarily say that for a galvanic cell, there is a conversion of chemical energy to electrical energy. And also for a galvanic cell, there is always what? Electrons leaving what? The anode to the cathode. For a galvanic cell, there is also a spontaneity of reaction. The opposite is for the electrolytic cell. I am sure we've learned something great today from the electrolytic cell. Do not forget that I have a channel and handles. Don't forget to share, don't forget to like, don't forget to subscribe, comment, and also to follow. Until we see again in our next class, it's been nice having you. It's goodbye.